we've done the arithmetic sequences, now we're with geometric sequences. Now the difference is that arithmetic sequences have a constant difference, which is actually first difference, which is actually still linear patterns. They've just been given a new name. Quadratic patterns have a constant second difference. But this isn't a constant first or a constant second difference. There is, just for an example, there is something happening here all the time. Okay, tell me what happened here all the time.
Times 3.
It's times 3. What type of a number pattern is that? The new one. If you time continuously with something, it's called a geometric sequence. There's nothing to do with geometry. It's called a geometric sequence. Alright, now for a geometric sequence, we need to look at R. There's a constant timing with 3. I don't even want to write it that way because it's going to confuse you with your little spider webs. The general term is going to be nothing new. A is your first term, stays first term. But now R is the new thing. R is your constant ratio. That's what the R stands for. But what is a ratio? Ratio is something like 1 to 2, 2 to 3. But how can I write 2 to 3? 2 over 3. Because ratios can be written as fractions. And the R is what you time by. The D is what you add by. Even if it's minus 2, you're adding minus 2, minus 2. Maybe yes, you're subtracting, but you're adding with minus 2. The R is what you are multiplying by. So that is your R. And how you get it is by taking term 2 and dividing it by term 1, term 3 and dividing it by term 2. With D, what did we say? D is when you take term 2 minus term 1 and it will be equal to term 3 minus term 2. It's the facts. So for these ones, let's have a look at an example. So this meant that my R was equal to 3. But is it right? 12 divided by 4. 36 divided by 12 still stays 3. Are you with me? Let's have a look at this example. What is my A value? 72. But what is my R value? And is it an R sum? Because we have to double check that it's 24 over 72 or 8 divided by 24. If I had another one coming, it would be, okay, that would have been the next one. See if you can find it. 24 divided by 72 is 1 over 3. 8 divided by 24 is 1 over 3. Double, triple check. And this fraction divided by 8 will still be 1 over 3. That's what I times by. I'm not going to write that every time. It's just a little note for yourself. It's what you time by continuously to get to the next one. So if you wanted to get to the next term, because sometimes we do ask that, what's the next 2 terms? What would you do? Times with a third would give you 8 over 9. Are you with me? Times with another third would be 8 over 27, because you're timing with a third. The question here wasn't that. The question was, there's the sequence. Find me term number 10. Find me the 10th term. So I need the Tn formula, which is now a new formula, which is on your formula sheet, which you must know of by heart. So I know what A is and I know what R is, but what's happening here? Again, tell me quickly how I'm going to make you have a shortcut. So for term 10, that should be 9. Are you going to get there quickly? That will always be 1 less out of the nature of the formula. A was 72, R was a third. So how many marks so far? Lots of explanation, but it's only 1 or 2 marks. Knowing that you must use the geometric formula and substituting your A and your R with the correct thing. And then only for the answer. Term 10. Do you think it's going to be a fraction?
Yes.
If you saw my pattern here, 8 over 3, 8 over 9, 8 over 27. I'm quite sure it's going to be 8 over something. Do you agree with me? You follow that pattern? Because once it's 8 over 3, 8 over 9, 8 over 27, it's going to keep on being 8 over something to the power of 3. How much is it?
2187.
And please don't do that in decimals. Leave it. The moment you go to your calculator and it gives it to you in a normal fraction form like this, you leave it like that. Just for interest's sake, quickly make that 9 on your calculator 20. What would it be?
0.0.
Okay, now I'm going to leave it as 0 point something something. Why? If the calculator takes it to a decimal, it's because it's quite small. All of these are 0 comma. The next ones are going to be 8 over 9 is already going to be 0. 8 divided by 9 is 0 comma. And it'll keep on growing all smaller, smaller, smaller. So it will be 0 comma. Point that I'm making is, if this was, for instance, a 20, you were busy with term number 21, right? But the point was, if it's given on a calculator as 0 comma something, 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 then you write that. But if it's given as a normal fraction, that's what you write. You don't take it to decimals, because this is more accurate than decimals, because decimals have to be rounded off, which is a little bit more inaccurate. Not inaccurate, but there's a difference in the rounding. Okay, and that's the term. Number 3C example says, if this is the sequence, 9, 3, 1, what's the pattern? Divide by 3. You're talking right, but what is R? 1/3. It's what you time by. And how do we double, triple check? That R is equal to 3 over 9. 1 over 3. There it is. You can write it every time. Term 2 over term 1. Term 3 over term 2, and it must be constant. And A was 9. But now the question is, how many terms are there in the sequence if they're giving me the last one? So what must I do? See which term is, and then I've got a new term for me, namely AR to the n minus 1. Now I know what A is, I know what R is, I know the answer, so I'm going to solve for what type of an equation is this?
Exponential.
Okay, so you know your toolbox. Quadratic equations, linear equations, exponential equations. So in the back of your mind you're getting the tool that says if it's exponential, we should be headed for something like 2 to the n is equal to 2 to the 3. And deducting logically that n is 3. So that's what we're aiming for here. Okay, let's have a look at it. A is 9, R is a third. Okay, how am I going to get to that? First of all, divide by the 9 so that it's gone. Can you divide these two by each other? Because that's part and parcel of that one. You can't just take the 3 away from it. That's a unit. You can't divide the 9 and the third or time them with each other. But you can take the 9 away by saying, take that and divide it by 9. And give me the answer, please. 1 over a lot. 1?
9, 6, 8,
6, 8? 3. Guys, I have a feeling. I have a feeling. I just need to know what that exponent there must be, because I know where I'm aiming. Because it's an exponential equation. How will I find out what that is? I'm going to put 1 over 19 whatever into the calculator. Just put 19683 and get the prime factors, which should be 3 to the, I don't know, something. Fact of 19683 is to the power of? Is it 9?
yes.
And what about the 1? Well, 1 to the power 9 is still 1. And then my deduction, logical deduction, n minus 1
is equal to 9.
is it no. It's a third, right? So if I wanted to write 3, for instance, could I swap both of them around? And then it would have been 3 to the power of minus 9, right? But my bases are the same, whether they're 3 or a third. Both of them are the same. So I'm making the deduction that n minus 1 is equal to, and n is equal to. So that means the 10th term would have been 1, 2, 8, 7. Can you check it? You don't have time in a test, but you have time now. You can go back here and say, if this is equal to 9 for the 10th term, work it out on the calculator, and it is 1 over 2187. Number 4, I want to read with you. Says, determine R if the first term is 2. Please interpret that into math language. Determine R if the first term is 2. So I'm looking for R. T1 is correct, but you realize that it's A. Term 1 is 2. And then they say the 8th term is equal to. Interpret. T8 is equal to 4374. Okay, how's that going to help me? What do I use? Always? Formulas. So the formula for T8, tell me I'm wrong. Yes, ma'am, you're wrong. Because we're not busy with arithmetic, we're now busy with geometric. Do you see the choices you've got to make? Alright, so this will be A R to the 7 because I'm busy with geometric. And they did say, determine R. They don't have to say in a geometric sequence if they say find R, because they're telling you it's geometric because they're finding R. Okay, geometric. I know what A is, so basically it's the same type of a question that we've just done now. Now I know I'm going to try and find the R. First of all, divide by 2, and that gives me what? And then I must do what? 7th root. And that gives me? Happy? The question was find R. I'm done. Can I not maybe go and look what the sequence looked like? Since we now have time, we can, but not in a text. If I wanted the sequence, where would I start? At 2. And then what do I do? Times by 3. And times by 3. And times by 3. And if I keep on doing that, I would get to the 8th term being 437. But you don't have time for that. Now you do, so you can quickly go and do it again and again and again and see that it is. It will be. Okay. I need to read the sum with you so that you can see where it comes from. Because question number 8 says, determine the first 3 terms of a geometric sequence with the second term minus 12 and the 5th term minus 786. What must I do? Write it mathematically. The second term minus 12. T2 is minus 12. And the 5th term, T5, is negative 786. And they've got to look at their sum to see. They can't just say, it's minus 780. It's got to be something that's going to work. Okay? Otherwise, there's a mistake. Let's have a look. So the only thing I have is my which I'm going to use my formula. So this will be AR to the 1, right? So you with me with that formula all the time? And then that should be AR to the 4 all the time. This would be negative 12, negative 786. What have we here? simultaneous equations, but worse, because now there's exponents. In arithmetic, it's linear. Now there's exponents, but it's all the work that you've done. How would I approach this? Elimination. Not a chance. Elimination only works if it's linear and linear and you can get the coefficients the same so that you can eliminate. So elimination is limited, where substitution always works. Sometimes it's not the best, better one of the two, but it always works. How would I substitute? What would you do? Either A or R alone. Now this particular sum wasn't a problem to get R alone and then substitute it into that one. But in general, if it's AR to the 6 and AR to the 10 and AR to the whatever, the easiest thing to get alone is A. But you had a choice in this particular question. A is equal to negative 12 over R and this side as well. And I don't have to, because I can now substitute this A here with negative 12 over R and carry on with the sum. I just like doing it this way and getting both of them equal to A just because I can. No particular reason. And then call this my number 1 and my number 2 equations. If I put them into each other, they're basically the same. Why? Because A is, and A is, and A is the same A, so they have to be equal to each other, making it minus 12 over R equals minus 786 over 7. Sorry, R to the power of 4. Happy on that? Okay. So now what? Guys, I've got to solve for R. Ideas? There are 2 R's, so get them together. Okay, you're doing what I want you to do. Or what's this? Cross multiplication, you remember? So I'm taking that one to this side. Now I have a reason why I want to rather take the R to the 4 there rather than take the R there. Because the only reason is I like to always have the bigger one of the exponents at the top. But it doesn't matter, because if you've got both of them at the bottom, you can just flip them both at one stage, because it's all the alternative steps in between. So what I'm doing is timing by R to the 4 there and there. Then I'm going to divide away the 12 and it's going to give me over the minus 12. So you see it being swapped. But there's method to this. You have timed with R to the 4 on either side. You have divided by minus 12 on both sides. And my answer is then R to the 3rd, because it's exponent laws. And this answer would be plus what? Say again?
1, 3, 1, 2.
No.
1, 3, 1, 2.
Okay, I think there was a mistake. I'm sure it was a mistake. Let me just check the Afrikaans textbook, guys. Yes, guys, I remembered it. There was a mistake. Originally, they've got it in the textbook as 786. They just made a typing error, swapping them around. That made that this thing doesn't really work out nicely for us for an R that actually properly works. It's not to say that R can't be a fraction. There's lots of fractions. But that one was a little bit weird to work with the fourth root as well. So okay, there's the correct one then. So if I do divide, it gives you 64. To get to the R, you say cube root and you get 4. And the question was, find the first 3 terms. Have I done what I wanted to do? Find the first 3 terms. I've got R. I still need to find A, and if I find the A, then I can find my first 3 terms. How am I going to get there? Go back to either one of them. So A would be equal to minus 12 over R, that is 4, so that's negative. Yeah, at least I've got now A. I'm still not done. I've got the first term, but I don't have the first 3 terms. So the first 3 terms are negative 3 is the first one, and then you times by 12 and by 12 by 4, and you times by another 4. And if you want to time by another 4 and give me the next answer, I'm going to deduct them all. More is okay, but not less. Don't only give me 2 if I'm asking for 3. That's okay. Alright. Okay, so your homework is on exercise 1.54, guys. It is a little bit rough. You've got to interpret things like, for instance, the sum of the 5th and the 8th term is 20. How would I write that? The sum of the 5th term and the 8th term is, say for instance, 80. Be careful that you don't say the word, the moment I say the sum of, that you want to write S in. Just be careful for that, okay? Then keep in mind that you're constantly going to be busy with exponent laws. Stuff that you've done in grade 11 that we didn't particularly do now.